Imagine standing on a beach, holding a handful of sand, each grain a moment in time. Now imagine that all of human history, every war, every empire, every invention, fits on just one grain. The rest? Billions of years. Deep time. And somewhere in that vastness, there might be grains we'll never see. Grains that held civilizations before us. Civilizations that rose, built, and vanished so completely that even their fossils turned to dust. This isn't science fiction. It's geology. And it's terrifying. Welcome to the Silurian Hypothesis. The year is 2018. Two scientists, Gavin Schmidt, a climate modeler at NASA, and Adam Frank, an astrophysicist, are sitting in a restaurant. They're not talking about aliens. They're talking about us. Specifically, how would future geologists know we existed? If humanity disappeared tomorrow, what will we leave behind in the geological record? The conversation takes a darker turn. What if someone else had asked the same question? Not in the future, but in the deep past. What if 100 million years ago, another species rose to intelligence, built cities, burned fossil fuels, and then collapsed? Will we even know? Schmidt and Frank published a paper. They called it the Silurian Hypothesis, a cheeky reference to Doctor Who, where intelligent reptiles ruled Earth before humans. But the science? Deadly serious. Because here's the uncomfortable truth. Geology is not a perfect record. It's a book with most of its pages torn out. And the deeper you go, the fewer pages remain. So let's ask the question no one wants to answer. Could we actually be the first? To understand why this matters, you need to understand deep time. Not thousands of years. Not even millions. We're talking hundreds of millions. Humans, modern Homo sapiens, have existed for about 300,000 years. Industrial civilization, roughly 200 years. In geological terms, that's a blink, a breath, a single frame in a billion-hour film. Now here's the problem. The older the rock, the rarer fossils become. Erosion, plate tectonics, volcanic activity. They grind everything down. Sedimentary layers get subducted into the mantle. Mountains rise and crumble. Coastlines shift. Entire continents drift apart and collide. In fact, less than 1% of all species that ever lived left fossils. And of those, only a fraction are ever found. So, if a civilization existed 100 million years ago, say, during the Cretaceous period, and lasted only 100,000 years, what would remain? The cities? Gone. Concrete crumbles. Steel oxidizes. Glass melts. Plastics degrade under UV light and microbial action. Even our most durable structures, pyramids, dams, skyscrapers, will be unrecognizable rubble within a few million years. Subduction zones would swallow the rest. But surely we find fossils, right? Skeletons, bones, tools, maybe. But consider this. We've only found a few dozen complete T-Rex skeletons. And dinosaurs ruled Earth for 165 million years. If an intelligent species existed for just 100,000 years, and their population was small, the odds of finding a fossilized individual are microscopic. So what would survive? This is where Schmidt and Frank's hypothesis gets truly fascinating. Because while bones crumble and cities vanish, chemistry lingers. When we burn fossil fuels, we release carbon. A lot of it. This carbon has a distinct isotopic signature. Carbon, 12 versus carbon, 13 ratios that differ from natural sources. And this signature gets trapped in sedimentary layers. Ice cores, ocean floors. If another civilization industrialized millions of years ago, they'd leave similar spikes. Carbon anomalies, nitrogen compounds, plastic polymers, synthetic chemicals. The question is, will we recognize them, or will we assume they were natural? Here's a chilling example. The Paleocene-Eocene Thermal Maximum, or PTM. About 56 million years ago, global temperatures spiked by 5 to 8 degrees Celsius in just a few thousand years. Carbon isotopes went haywire. Ocean acidity increased. Species went extinct. Scientists blame volcanic activity. Methane released from melting permafrost. Natural feedback loops. But what if it wasn't entirely natural? What if some of that carbon came from industry? From fossil fuels burned by a species we'll never meet? Now, to be clear, there's no evidence this happened. The PETM is almost certainly natural. But the point is, we wouldn't necessarily know the difference. The signals could look identical. And that's the terrifying beauty of the Silurian Hypothesis. It's not saying ancient civilizations existed. It's saying, if they did, we might never prove it. But there's one more clue, one we're creating right now. In 2016, scientists proposed a new geological epoch, the Anthropocene, the age of humans, defined not by fossils, but by what we've left behind. Plastic, concrete, radioactive isotopes from nuclear tests, aluminum, chicken bones in landfills. These are called technofossils, artificial markers that will persist in rock layers for millions of years. Future geologists will find a thin, distinct layer, the Anthropocene boundary, a line of plastic, metal, and ash that screams. Something intelligent was here. But here's the paradox. That layer will be thin, maybe a few centimeters, maybe less, compressed over millions of years into a faint chemical signature. Now imagine you're a geologist 100 million years from now. You're drilling through ancient rock. You hit a strange layer. Carbon spikes, nitrogen anomalies, rare earth elements. It's only a few millimeters thick. Do you conclude an intelligent species industrialized here? Or do you write it off as volcanic activity, meteorite impact, or natural climate fluctuation? The truth is, you probably never know. And if we can leave such an ambiguous trace, what's to say others didn't do the same? So let's look at the actual evidence, or lack thereof. In 2019, a team of geologists examined sediment cores from the last 500 million years. They were looking for anomalies, unexplained chemical spikes, rapid temperature changes, extinction events that didn't fit. They found nothing conclusive. No smoking gun. No definitive layer that screamed industrial civilization. But, and this is key, the geological record is so incomplete, so eroded, that proving a negative is nearly impossible. Consider the Cambrian explosion. 542 million years ago, life went from simple organisms to complex, diverse ecosystems in a geological instant. We still don't fully understand why. Or the Ordovician-Silurian extinction. 444 million years ago, 85% of marine species died. Glaciation, sea level changes, oxygen depletion. Natural causes, probably, but we'll never be 100% certain. The deeper you go, the murkier it gets. And this brings us to the most unsettling implication of the Silurian Hypothesis. We might be surrounded by ghosts we can't see. Not literal ghosts, but the faint, eroded traces of worlds that came before. Civilizations that rose, fell, and were swallowed by time. Their cities ground to dust. Their bones lost to subduction. Their stories never told. But why does this matter? Why should we care about hypothetical civilizations that may never have existed? Because the Silurian Hypothesis isn't really about the past. It's about the future. Schmidt and Frank weren't just asking, could others have existed? They were asking, if we disappeared tomorrow, what will we leave behind? And the answer is humbling. Our plastic will degrade. Our steel will rust. Our cities will crumble. Even our nuclear waste will eventually decay. In 100 million years, the only trace of humanity might be a thin layer of strange chemicals and a spike in carbon isotopes. Future geologists, if they exist, might never know we built the internet, that we went to the moon, that we wrote poetry, composed symphonies, and asked whether we were alone. They'll just see noise, ambiguity, a geological blip. And this forces us to confront an uncomfortable truth. Sustainability isn't optional. Because if we collapse, if we burn through our resources, destabilize our climate, and vanish, we won't even leave a warning for whoever comes next. The Silurian Hypothesis is a mirror. It shows us what we might become. Forgotten, erased, a footnote in deep time. But it also shows us what we could avoid. In the end, the Silurian Hypothesis isn't about proving ancient civilizations existed. It's about humility. Humility in the face of deep time. Humility in the face of our own fragility. Earth is 4.5 billion years old. Life has existed for 3.7 billion years. Complex life for 600 million. And we've been here for a fraction of a percent. We are not inevitable. We are not permanent. And maybe that's okay, because whether or not others came before us, the question remains the same. What will we leave behind? The stones are quiet. They don't judge. They simply record. And one day, millions of years from now, someone else might stand where you're standing. They'll drill into ancient rock. They'll find a thin layer of strange chemistry. And they'll wonder, what were they like? Did they know how fragile they were? The answer is up to us. Thanks for watching.